Welcome back, fellow improvement enthusiasts. Today, we're diving deep into the realm of process enhancement, focusing on the indispensable 7 basic quality tools. Whether you're a seasoned professional or new to the world of process improvement, these tools are your gateway to achieving operational excellence. The 7 basic quality tools for process improvement. The 7 basic quality tools for process improvement are a set of fundamental techniques used in quality management and continuous improvement initiatives. These tools, also known as the 7QC, quality control tools, were first conceptualized by Kaoru Ishikawa, a Japanese quality management pioneer. They are: Checksheet, a simple data recording tool used to collect and tally data. It helps in organizing and analyzing information, such as defects, occurrences, or frequencies. Histogram, a graphical representation showing the frequency distribution of data. It helps visualize variations, identify patterns, and understand the distribution of a process. Cause and effect diagram, fishbone or Ishikawa diagram, a visual tool used to identify potential causes contributing to a specific effect or problem. It categorizes causes into branches like people, process, equipment, environment, etc. Pareto chart, based on the Pareto principle, 80-20 rule. This chart displays the vital few causes contributing to the majority of problems. It prioritizes issues for focused improvement efforts. Scatter diagram, used to explore relationships between two variables. It helps in determining if changes in one variable are related to changes in another, showcasing correlations or lack thereof. Control chart, a tool for monitoring process variation over time. It distinguishes between natural variation and assignable causes, aiding in maintaining process stability and identifying deviations. Flowchart, a visual representation of a process that outlines the sequence of steps and decisions involved. It helps in understanding, documenting, and improving processes by identifying inefficiencies or bottlenecks. These tools serve as foundational aids in problem-solving, process analysis, and decision-making within various industries and organizational contexts. They empower teams to systematically identify issues, analyze data, and make informed improvements to achieve better quality and efficiency in processes. History of 7 basic quality tools for process improvement. The history of the 7 basic quality tools traces back to the mid-20th century, emerging primarily from the work of quality management pioneers in Japan, notably Kaoru Ishikawa. These tools were developed as a means to enhance quality control and process improvement methodologies. During the post-World War II era, Japan was undergoing significant reconstruction, and there was a pressing need for economic recovery and quality enhancement in manufacturing. The concepts of statistical quality control, popularized by figures like W. Edwards Deming and Joseph Juran, were gaining traction. Kaoru Ishikawa, a professor at the University of Tokyo and a key figure in the Japanese quality management movement, contributed significantly to the development and promotion of these tools. He emphasized the importance of involving everyone in an organization in the quality improvement process, not just specialists. In the 1960s, Ishikawa highlighted a set of fundamental tools that could be easily understood and applied by individuals across various levels of an organization. These tools were not only effective but also user-friendly, making them accessible to workers on the shop floor as well as managers and quality professionals. The concept of the 7 basic quality tools gained momentum in the 1970s and 1980s as Japan's manufacturing sector gained global recognition for its quality standards. These tools became integral components of total quality management (TQM) practices and were adopted by industries worldwide. The tools were designed to be simple yet powerful, providing structured approaches to problem-solving, data analysis, and process improvement. They enabled organizations to identify issues, analyze data systematically, and make informed decisions for continuous improvement. Over time, these tools evolved and were adapted to suit various industries and quality improvement contexts. They formed the foundation for further quality management methodologies, including Six Sigma, lean manufacturing, and continuous improvement, emphasizing the importance of data-driven decision-making and problem-solving techniques. Today, these 7 basic quality tools remain relevant and widely used across industries as essential instruments for achieving and maintaining high standards of quality and process efficiency. They continue to serve as fundamental pillars in the pursuit of continuous improvement and organizational excellence. How to develop it step by step. Developing and implementing the 7 basic quality tools for process improvement involves several key steps. Understand the tools. Educate yourself and your team about each tool's purpose, functionality, and application. There are numerous resources available, including books, online courses, and tutorials that can provide in-depth explanations and examples. Identify a problem or process to improve. Choose a specific area or process within your organization that needs improvement. It could be related to quality issues, inefficiencies, or bottlenecks. Gather relevant data. Collect data related to the identified problem or process. Ensure that the data collected is accurate, relevant, and sufficient for analysis using the selected tools. Select the appropriate tools. Based on the nature of the problem and the type of data collected, choose the most suitable tools from the 7 basic quality tools. For instance, if you're dealing with data distribution, a histogram might be appropriate. If you're trying to identify potential causes, consider using a cause and effect diagram. Apply the tools. Use the chosen tools to analyze the data and gain insights into the problem or process. Follow the steps outlined by each tool and input your data accordingly. Interpret the results. Once you've utilized the tools, interpret the results. Look for patterns, trends, correlations, or areas of focus that the tool reveals. This analysis will help you understand the root causes or areas requiring improvement. Brainstorm solutions. Based on the insights gained, brainstorm potential solutions or improvements. Encourage team collaboration to generate diverse ideas and strategies. Implement improvements. Select the most viable solutions and create an action plan for implementation. Ensure that responsibilities, timelines, and resources are clearly defined. Monitor and evaluate. Put the improvements into action and continually monitor the process. Use the tools periodically to assess the effectiveness of the changes made. Adjust strategies if necessary to ensure sustained improvement. Document and communicate. Document the entire process, including the data, analysis, solutions, and outcomes. Share the results and lessons learned with relevant stakeholders to promote transparency and continuous learning. Provide training and support. Train team members on using these tools effectively. Encourage their participation and provide support as they apply these tools in their respective areas. Foster a culture of continuous improvement. Emphasize the importance of using these tools regularly and integrate them into your organization's culture. Encourage feedback, innovation, and a commitment to ongoing improvement. By following these steps systematically and integrating the tools into your organization's practices, you can effectively develop a culture of continuous improvement and enhance overall quality and efficiency. Benefits and importance. The 7 basic quality tools hold significant benefits and importance in the realm of process improvement and quality management. Structured problem solving. These tools provide a structured approach to problem solving. They guide teams through systematic processes, helping to identify, analyze, and resolve issues efficiently. Data-driven decision-making. They promote data-driven decision-making by enabling organizations to collect, organize, and analyze data effectively. This ensures decisions are based on empirical evidence rather than assumptions. Root cause identification. By utilizing tools like the cause and effect diagram and Pareto chart, these tools assist in identifying root causes of problems. This prevents treating symptoms and facilitates the resolution of underlying issues. Visualization of data. Tools like histograms, scatter diagrams, and control charts facilitate the visualization of data. Visual representations make it easier to understand complex data patterns and trends. Prioritization of efforts. The Pareto chart, based on the Pareto principle, 80-20 rule, aids in identifying the most critical issues contributing to problems. It helps in prioritizing efforts and resources towards areas that will have the most significant impact. Process monitoring and control. Control charts are instrumental in monitoring process variations over time. They distinguish between natural variation and assignable causes, allowing for timely interventions to maintain process stability. Enhanced communication. These tools facilitate better communication among team members and stakeholders. Visual representations and structured methodologies make it easier to convey complex information and findings. Efficient problem solving. They streamline problem-solving processes. By providing a common framework and language, these tools reduce ambiguity and ensure a consistent approach to addressing issues. Continuous improvement. The tools foster a culture of continuous improvement within organizations. They encourage ongoing analysis and optimization of processes, promoting a mindset of striving for excellence. Empowerment and engagement. Involving employees at all levels in using these tools empowers them to contribute to quality improvement initiatives. It fosters a sense of ownership and engagement in making processes better. Cost savings and efficiency. By pinpointing and addressing inefficiencies or quality issues, these tools contribute to cost savings through improved processes and reduced waste. Adaptability to various industries. The versatility of these tools allows their application across diverse industries, including manufacturing, healthcare, service sectors, and more. Implementing and utilizing these tools effectively can result in substantial improvements in quality, productivity, customer satisfaction, and overall organizational performance. Their structured approach and emphasis on data analysis make them indispensable assets in the pursuit of operational excellence. Examples. Here are examples illustrating the application of each of the 7 basic quality tools in various scenarios. Check sheet. Example. In a manufacturing plant, a quality control team uses a check sheet to record the number of product defects observed during a shift. They tally defects such as scratches, dents, or missing components. By the end of the day, they have a comprehensive count of each defect type, aiding in identifying the most prevalent issues. Histogram. Example. A customer service team creates a histogram to analyze the response times for resolving customer queries. They categorize the response times into intervals, e.g., 0-15 minutes, 16-30 minutes, etc., and plot a histogram. The graph reveals that most queries are resolved within 0-15 minutes, but there's a significant spike in the 16-30 minute range, highlighting a potential area for improvement. Cause and effect, fishbone diagram. Example. A hospital uses a cause and effect diagram to address patient waiting times in the emergency room. They identify categories like staffing, processes, equipment, and patient influx as potential causes. Upon analysis, they find that limited staffing during peak hours and inefficient triage processes contribute most significantly to prolonged wait times. Pareto chart. Example. An e-commerce company creates a Pareto chart to address customer complaints. They list various complaint categories like shipping delays, product quality issues, and customer service problems. The chart reveals that shipping delays and product quality problems account for 80% of total complaints, prompting the company to prioritize solving these issues first. Scatter diagram. Example. A marketing team uses a scatter diagram to analyze the correlation between advertising spending and sales revenue. By plotting the data points for different advertising budgets against corresponding sales figures, they notice a positive correlation, indicating that increased spending leads to higher revenues. Control chart. Example. A software development team utilizes a control chart to monitor the number of bugs reported in each software release. Over several releases, they plot the number of bugs found. The control chart helps them differentiate between normal variation and significant spikes, allowing them to investigate and address unusual increases in reported bugs. Flowchart. Example. A logistics company creates a flowchart to map out their order fulfillment process. The flowchart outlines each step from order placement to delivery, including decision points like inventory checks and shipping methods. By visualizing the process, they identify redundant steps and streamline the process for quicker order processing and delivery. These examples showcase how each tool can be applied in different contexts to analyze data, identify issues, and guide improvement initiatives in various industries and departments. Conclusion. And there you have it, our comprehensive overview of the 7 basic quality tools. Remember, mastering these tools isn't just about acquiring knowledge. It's about implementing them to drive meaningful change and continuous improvement in your organization. Thanks for tuning in. Don't forget to like, share, and subscribe for more insightful content. Until next time, keep improving and excelling. This is Bilal Consultancy, signing off.